Hello, this is Kassian with NetApp Instaclustr. Today, you'll learn enough to chat about machine learning. This video is part of a series called Learn Enough to Chat About Tech. To see other videos in the series, there are links in the description. First, I'll cover what machine learning, or ML, is, and the feedback loop of machine learning. Then, I'll cover the types and categories of ML. Then I'll cover ways that technologies you may already use are supporting the AI and ML spaces. Finally, you will hear about some use cases for ML. First things first, I'll talk about what ML is. Machine learning is a subset of artificial intelligence, or AI, which is the concept of emulating human intelligence via computer program. ML deals with the learning and data synthesizing steps, taking in data and making new conclusions based on that data in a way similar to humans when learning. This is done using models. These are programs that detect patterns and make conclusions using different algorithms and base datasets. For instance, large language models, or LLMs, are models that are tuned to detect and generate human speech. When data is fed into an ML model, it can have both a value and a label. This value is called a feature, and it represents some piece of data. Labels help with learning algorithms, as I'll discuss shortly. Next, let's discuss the main feedback loop for machine learning. The main processing loop starts when a piece of data enters the ML program. The data is prepped for the model, then fed into it. The model provides a conclusion. Then, in reinforced learning, feedback is provided to the model about its solution. Was it right? Was it even close? This feedback tweaks the algorithm of the model, and the process starts again with the next piece of data. This is shown in the diagram. Next, I'll cover the categories of machine learning. Machine learning is divided into three categories: supervised, unsupervised, and semi-supervised. The main difference between them may seem minimal, but each serves very different use cases. The designation of supervised depends on whether features have labels when fed into the model. When every feature has a label, you have supervised learning. Supervised learning is used when you have labeled sets of features and would like to categorize and label new features based on that existing data. An example of this is song recommendations. Say you have a set of liked songs, and you want to use that to know if a user is likely to enjoy, and therefore should be recommended, a new song. Unsupervised learning, by comparison, has no labels on features on ingestion. The model looks for patterns in the data and assigns labels accordingly. Unsupervised learning is used for tasks like anomaly detection, where you want the model to spot patterns for you rather than providing them, as in supervised learning. Semi-supervised learning is an interesting use case where some, but not all features have labels. These are usually used to train models. Training a model involves giving it some labeled features and many unlabeled ones, then providing feedback to the model about conclusions it draws on the unlabeled data, as we discussed in reinforced learning. This allows the model to learn from data. Now I'll talk about the different ways that technologies are adapting to support ML technology. ML relies on a technology called vector databases or vector storage, where features are simplified to a vector that can be numerically compared to other vectors. Vector databases are being implemented in or are supported by many technologies in the open source space. For instance, Apache Cassandra recently added support for vector storage in 5.0, and PostgreSQL has it as well. K-nearest neighbor, or KNN search, is vital to machine learning. It allows you to query for items not by exact matches, but by gathering vectors nearest to the target vector based on the features the vector represents. KNN is available on Apache Cassandra 5.0 and OpenSearch, as well as PostgreSQL and many others. The diagram on the slide represents a KNN search, where the red dot is the target node. The black circle is the acceptable distance from the target node. Two nodes would be returned in this search, the ones inside the range of the black circle. The next feature is indexing, where data is stored in such a way that it can be easily searched using complex algorithms and search types, such as full text search, semantic search, and others. Scalability is a key feature of vector databases, and the amount of data needed for ML is exponentially increasing over time. Finally, I'll talk about the use cases of ML. Supervised learning can be used for image recognition, sentiment analysis, or data analytics. Unsupervised learning is great for things like data classification, anomaly detection, market classification, or anytime you need to classify large amounts of unlabeled data. Semi-supervised learning is exceptionally good at training models using reinforced learning. Let's review. In this video, you learned about machine learning, a process which allows computers to learn new things on their own. This is done using models, algorithms that classify and detect patterns in data. Supervised learning is when all of the data, called features, have a label, and this is used to classify new, unlabeled data. Unsupervised learning is when none of the features are given with labels, and this is used to find new categorizations and patterns in data. Semi-supervised learning is when some features are labeled and some are not, and this is mainly used to train models. Training models involves giving it labeled and unlabeled features and giving the model feedback about the labels it gives to the unlabeled data, allowing it to learn. There are many ways technologies are adapting to support machine learning. These include vector storage, k-nearest neighbor searching, scalability, and indexing. These features are supported in many open source technologies, such as Apache Cassandra, PostgreSQL, and many more. There are many use cases for each type of machine learning. Supervised is great for classifying data, unsupervised is good at detecting patterns and anomalies in data, and semi-supervised is great at training models. Thank you for watching. If you'd like to see more, click the like and subscribe button to be alerted when new episodes come out.